Welcome back to the deep dive.
Good to be here.
So today we're tailoring things a little bit. We are stepping into what I think, a lot of people consider the absolute deep end.
The deep end of the programming pool, for sure.
We're talking about functional programming and specifically the big one.
Oh, yeah.
The boss level, Haskell.
Haskell. Yeah, just saying the name is enough to make even seasoned developers, start sweating a little bit.
It is.
It's got that reputation, doesn't it? Purely academic, incredibly math-heavy.
Intimidating.
And honestly, just intimidating.
Yeah, it really does. It feels like you need a PhD in category theory just to write hello world.
Right.
It's like the Latin of programming languages. Beautiful, but, nobody speaks it at the grocery store.
Mm-hmm.
But, and this is exactly why we're here, we found a source that cuts through all that intimidation factor.
In a way that's just really refreshing. It's not a textbook. It's not some lecture from an ivory tower.
Not at all. We're diving into a blog post from a series called Notes on Haskell Programming, specifically Part 35.
Part 35.
This was published just recently, January 19th, 2026. And the author goes by Ang, or Kian Meng.
And just that number, Part 35, it implies a long, committed journey.
Is a journey. And our mission today is to tackle a very specific, very common headache in Haskell.
Okay.
We're going to figure out the difference between, regular functions and what are called wrapped functions.
Which, that sounds incredibly dry on the surface. Wrapped functions.
Super dry. It sounds like something from a legal contract.
It does. But
Yeah.
stick with us, because the way Ang explains this,
Yeah.
it's just brilliant. He uses this tangible, real-world analogy.
The tools on a workbench versus tools in a box.
Exactly. And it is the key to unlocking one of the most confusing concepts in functional programming.
We're talking about the applicative functor.
Mm-hmm. If you have ever stared at that little operator in code that looks like a TIE fighter.
The less than, asterisk, greater than symbol.
Yes. And just felt completely lost. This deep dive is going to be your map.
But before we even get into the code, I actually want to spend a second on the author, on Ang.
Okay.
Because usually when we read about Haskell, it's written by some computer science professor or researcher.
Mm.
Ang describes himself as an old software plumber.
I caught that too. Musings of an old software plumber. It sets a very different tone right off the bat.
It really does.
It lowers the barrier. It suggests, practicality over pure theory. He's interested in pipes that don't leak, not just the abstract purity of the water.
Exactly. It feels blue-collar in the best possible way. And looking at his blog, canmeng.org, this plumber mindset is just, it's everywhere.
Mm-hmm.
He's not just cranking out code tutorials to get clicks. He tracks everything.
What do you mean by that?
Okay, so we're looking at part 35 of his Haskell notes,
Right.
which is already impressive.
Right.
But I was scrolling through his site, and this guy is fascinating. He has notes on fish keeping.
Fish keeping.
Yeah.
Seriously. Or aquariums.
Yes. And he's got specific entries like decoding duckweed and betta spawn logs.
Wow.
He's tracking the biology of his tanks. He has notes on dieting, notes on photography, notes on home improvement.
He's a documenter.
And my personal favorite, notes on gardening. Do you want to take a wild guess what part number he's on for his gardening notes?
Well, we're on 35 for Haskell. So maybe part 100, 150.
Part 781?
No. 781.
Yes.
That is a staggering amount of gardening.
The upward growth of
Yeah.
something or other. He documents everything. And I think this context is crucial for understanding why this guide is so good.
It tells us a huge amount about his learning style. He's a systematic observer.
Right.
Whether he's figuring out why his ferns are yellow or why his Haskell code won't compile, he approaches it with the exact same rigor. He observes, records, iterates.
It's a field journal.
That's the perfect way to put it. It's not a textbook written after the fact, pretending the expert knew everything all along. It's a log of the struggle. It's, here's what I tried, here's what failed, and here finally is what worked.
I love that. It makes it all so much more accessible.
Mm-hmm.
So let's open up his field journal to part 35. Dealing with regular or wrapped values and functions.
All right.
Let's get into the plumbing. Ang starts with the baseline, the simple stuff, the regular function. And he uses this workbench analogy.
This is the mental model you want to start with. Imagine you're in a nice, clean workshop. You have a tool. Let's say it's a function that adds 1 to a number. It's just lying right there on the table.
It's just unwrapped.
Correct. Unwrapped. Nothing between you and the tool. You reach out, you grab it, you use it.
And in his code snippet, the example is just +1. You have the number 2. You apply the function.
Boom. You get 3.
Simple.
This is the happy path. In Haskell, the type signature for this is num AAILS AA. It takes a value, gives you a value, no barriers, direct contact.
Okay, so that's the workbench. Life is good, but then Ang introduces the conflict, the wrapped function.
Right. Now imagine that same tool, that same function, but it's not on the table anymore.
Okay.
It's inside a sealed cardboard box.
Right, I'm picturing it.
You know the tool is in there. There's a label on the box. But there is a layer of cardboard context separating you from it.
And in Haskell terms, this box is what they call a context, like maybe.
Exactly. He uses maybe. So the code changes from just +1 to just +1.
And the type signature shifts completely.
Dramatically. It's no longer a 2. It becomes maybe AA.
Okay, let's unpack this. So I have my box with the add 1 instruction inside, and I have a number, let's say 5.
Mm.
And I want to use the tool in the box on the number 5. So if I'm just, moving fast, I might try to just smash them together. I write just +1 5.
And Haskell immediately yells at you. It just stops the assembly line.
It does. And I love that the source actually lists the specific error code, GHC 83865.
Oh, yeah.
Because anyone who's tried to learn this language has seen this.
You've seen that. And that error is actually pretty telling if you learn to decode it. Haskell is saying, I expected a function here, but I found a maybe container.
It's like the compiler saying, I can't tighten this bolt with a cardboard box.
Precisely. You're trying to apply the box itself to the number. The language doesn't know how to do that. The tool is shielded.
And it gets even messier, right? Because usually your data is boxed up too.
That's the more common scenario, yeah. You don't just have a boxed function, you have a boxed value.
So you have just +1 and you have just 5. A tool in a box and a number in a box.
2 boxes sitting on the bench, and if you try to jam those 2 boxes together,
just +1, just 5.
Haskell throws another fit. It still doesn't know how to get the insides of 2 separate boxes to interact.
It's like trying to shake hands while both people are wearing oven mitts inside a safe.
That is a vivid image. And yes, so we're stuck. We have the ingredients, but they're trapped.
And this is where the old software plumber comes in with the solution.
The right tool for the job.
Ang introduces this operator. And if you've been doing Haskell for about a week, you've seen it, and you've probably feared it. It's
an applicative operator, often just called apply.
That looks like a little TIE fighter.
Yeah.
But what does this little star operator actually do? Ang describes it as a set of instructions.
Think of it as a specialized robot arm on that workbench. It's a protocol for handling boxes. When you put that operator between your boxed function and your boxed value, it performs a very specific choreography.
Choreography is a good word. So what are the steps? What's the robot doing?
Ang breaks it down into 4 steps. Step 1, the operator reaches into the first context, the first maybe.
And extracts the function, takes the tool out of the box.
Right. Tool is out. Step 2, it reaches into the second context.
And extracts the value. Takes the number 5 out of its box.
Number's out. So now that both things are unwrapped, step 3. It applies the function to the value.
It adds 1 to 5 to get 6.
But, and this is the crucial part, it doesn't stop there. Step 4.
It puts the result back into a box.
A new context. A new box. So the result isn't just 6.
It's just 6.
Exactly. The safety of the box is preserved.
Yeah.
You started with box things, did the math, and ended with a box thing. But you didn't have to manually rip open the cardboard. The operator did it for you.
That is actually really clean. So
yeah.
Just +1.
Yeah.
Just 5 results in just 6.
That's it. That is the magic of applicative functors. It handles the plumbing of the boxes so you can focus on the logic inside.
And this brings us to what I think is the most helpful part of the blog post. Towards the end, he provides this summary table.
Oh, I love a good cheat sheet.
Me too.
Yeah.
He breaks down the 3 ways you can apply things, depending on how wrapped up they are.
Right. And just a quick note, he uses square brackets in the text, not to mean a list, but just as a visual symbol for something within a box.
A generic container.
Right.
So tier 1 of the table.
Normal application.
Right.
Function plus data. FX, unwrapped tool, unwrapped material. This is what you do 90% of the time in Python or Java.
Tier 2. Functor application.
Here you have a regular wrench, but the bolt is in a box. So unwrapped function, wrap data. Ang says you use fmap or the operator.
And the result is F6X. So it effectively lowers the tool into the box to do the work.
Exactly.
And then the tier we just mastered, tier 3, applicative application.
Boxed function plus boxed data, both are wrapped. This is where you bring out the star operator. So FX.
You know what's fascinating when you look at that table is you realize most of the complexity isn't the logic. The logic is just add 1.
First grade math.
Right. The complexity is just managing the packaging.
That is a profound observation. And if we connect this to the bigger picture of why we use languages like Haskell,
Right.
that packaging matters a lot.
Why, though? Why not just work on the workbench all the time? Why box everything up?
Because the box represents reality. The box isn't just cardboard. It's maybe, meaning maybe the data isn't there. Maybe the database failed.
Wow.
Or maybe the box is either representing a potential error message. The box is handling the what-ifs.
Okay, so if you work on the workbench, unwrapped, you assume everything is perfect.
You do. And if a value is missing and you try to add one to it, your program crashes. It explodes.
Yeah.
The billion-dollar mistake, right? The null pointer exception.
Right. The screen goes blue, the app closes.
But if you work with boxes, the context handles the failure. If you try to use the applicative operator on an empty box, on a nothing, it doesn't crash.
What does it do?
It just sees the empty box, realizes there's nothing to do, and passes a nothing along.
So the cardboard is actually safety gear.
It's protective equipment, exactly. And tools like let you work while wearing the safety gear without it feeling clumsy. You can keep the hazmat suit on and still thread the needle.
That makes so much sense. And it circles right back to Aang being a software plumber.
Mm-hmm.
He's building pipes that don't leak when something unexpected flows through.
Or when nothing flows through them at all.
Right.
And I really think that's why he tracks all those other things, too. The gardening, the fish keeping, it's all connected.
How do you mean?
Well, think about an aquarium. You're managing an environment. You have parameters, pH, temperature, ammonia levels. Those are your contexts.
Okay.
If you just throw a fish, the value, into tap water without checking the parameters, the context, the fish dies.
That's a stark metaphor, but yeah, I get it.
Haskell forces you to acknowledge the water. It forces you to acknowledge the box. And Aang's notes are basically him figuring out the best way to maintain that environment.
So the living things inside can survive, you know. I was looking at that list again. Notes on Rust, notes on Elixir, but also notes on typesetting and notes on meditation.
He's a polymath.
But it's all the same process, isn't it?
Yeah.
It's, here is a complex system. How do I navigate it safely and effectively?
And how do I document it so I don't make the same mistake next time?
Exactly. I mean,
Yeah.
part 781 of gardening. That implies 780 previous observations.
That is dedication to the process. And that's what makes him a great guide for something like Haskell. He's not skipping steps.
It really is. So let's recap our deep dive, because we covered some heavy ground.
We did.
We started with this scary concept, applicative functors in Haskell.
Which turned out to be just a fancy way to handle tools in boxes.
We looked at Aang's analogy. A regular function is a tool on the bench. Easy.
+1, grab it and go.
A wrapped function is a tool in a box. Just +1. You can't use it directly because the cardboard, the context, is in the way.
You get error GHC 83865. The compiler says no.
So we need a special tool, the applicative operator.
The robot arm unpacks the function, unpacks the value, does the math, and repacks the result.
And we have that handy table. Unwrapped, normal application, boxed data.fmap, boxed everything.
Applicative? It's a roadmap for handling complexity.
So what does this all mean for you, the listener? Maybe you aren't coding in Haskell. Why should you care about tools and boxes?
I think the lesson here is about recognizing context.
Say more about that.
In any work we do, there's the task itself, the function, writing the email, fixing the sync, but then there's the context around it.
The cardboard around the task.
Right. Is the recipient of the email angry? That's context. Is the budget data reliable? That's context.
And we often try to ignore that context.
We do. We try to smash the task against the problem without respecting it. We send the joke email when the boss is in a bad mood.
And that's when we get error messages in real life.
Exactly. The applicative approach suggests we need a protocol. We need a way to acknowledge the context first, do the work, and then safely package it back up.
That is a really powerful way to look at it. It's not just syntax. It's a strategy for dealing with reality.
And that's why reading a blog by a software plumber who also gardens is so valuable. He sees the organic nature of these systems.
Speaking of organic, I have a final thought I want to throw out there.
Let's hear it.
We talked about his gardening notes, part 781, and we talked about software plumbing. It makes me wonder, is programming really just another form of gardening?
That's an interesting pivot.
Think about it. We usually think of coding as engineering, building a bridge. But you're not building a bridge that just stands there. You're managing an environment, the context, the box, to ensure the things inside, your data or your plants, grow correctly.
And you have to protect them from the harsh elements.
Right. Runtime errors are just, I don't know, frost. or pests.
The root rot?
Root rot, exactly. If you don't manage the drainage, the context, the roots rot. If you don't manage the, maybe cases, the code rots.
Yeah.
You're tending a system.
I like that. It takes the mechanical, cold feel out of coding and makes it feel more alive.
And it explains why someone would write 781 notes on gardening and 35 on Haskell. They're the same skill set.
Just different dirt.
Different dirt. I love it. So as you go about your week, look for the boxes. Look for the context wrapping up your problems. And ask yourself, do I have the right operator to handle this? Or am I just smashing cardboard against the wall?
That is the question.
Huge thanks to Ang at keyandmeng.org for the insights and for the tips on duckweed, because my tank is a mess.
Absolutely. Check it out.
And thank you for listening. We'll see you on the next deep dive.
Stay curious.